Let us now explore derivative of the function and find increasing and decreasing interval for the function itself. The question here is, find interval of increase and decrease for each function from the given derivatives. We have three examples here. We'll do them one by one. The first derivative is a linear function. The second one is a quadratic function. The third one is a rational function. So for three different kinds of derivatives, we will analyze and find increasing and decreasing interval for the function itself, right? So step number one is to find critical number, right? So that is our step number one, to find critical number. Critical number is a point where the derivative is either 0 or undefined So that is the point which we are looking for. Now in this particular case, f dash x equals to 2x minus 1. We can equate it to 0 and find the value of x. So we say 2x minus 6 equals to 0. That means x is equal to 3, right? 6 divided by 2. That means x equals to 3. In the case of second function, to find the 0 of the derivative, we can actually factor this, and we can write this equation as x minus 5 times x plus 1, right? So that will give us the same quadratic equation. And in the factored form, we can equate this to 0 and find the value of x. So it gives us two values of x. One is x equals to 5, and the other one is x equals to minus 1. In the third case, f dash x is 0. That means x plus 3 should be equal to 0, and that gives us one value, which is x is equals to minus 3. So there are these critical points which we need to analyze to find where on the function we have an interval where the function is increasing and the interval where the function is decreasing. So for that, what we will do is we will now analyze the first derivative itself. If first derivative is greater than 0, then the function is increasing, right? So that means the function is increasing. So that means increase f of x. Is that okay? So that is what it is. If it is less than 0, then the function is decreasing. So what we will do now is we'll check the nature of the derivative on different intervals around the 0. So at x equals to 3, we know we have a 0, right? So let us say this is the point where x is equals to 3 in the first case. We can take a test point on either side of this 0 for the derivative. Let us say the test point here is on 3. Let us say this test point is 0. Let's take this as 0. And on the right side, let us take a point which is 4. And when you substitute 0 in your derivative, then what is f dash 0? So in this case, f dash 0 will be negative, right? So here we find that f dash 0 is minus 6, which is negative, right? If I substitute 2, what do I get? F dash 4, the derivative, will be 4 times 2 is 8. 8 minus 6 is equals to 2, which is positive, correct? So what you really get is the derivative is negative. That means on the graph of the function, the tangent will be decreasing. That means the function is decreasing. And afterwards, it is increasing. Do you see that? So that is how you can figure out interval of increase and decrease from testing the sign of derivative around the critical number, right? So what we get here is, let me now make two sections here. We'll write down interval for increase in one column and interval for decrease in the other, right? So that will, I'll save some space. So in this particular case, we find that interval of increase is beyond 3, right? So interval of increase for this particular function is, let me use a different ink, which we have not used here so far. Okay, so we could write here as from 3 to infinity, it is increasing. So it is increasing from, let me write here, 3 to infinity. That is the interval of increasing. As far as decreasing is concerned, it is from minus infinity to 3. So it is decreasing from minus infinity to 3, right? So that is how we get our answer. Now let's look into the second derivative, analyze it in the similar fashion. So what we have here is we have two zeros. One is at minus 1, the other one is at 5. Now since this is a quadratic function, we could, and with a positive thing, we could actually draw a graph here, kind of like this. This is alternate way, graphical way. Now from the graph, we can see that the interval is increasing, since this is positive on this side, on the left side of minus 1 and on the right side of 5. And in between minus 1 and 5, the interval, in this interval, derivative is negative, so the function is decreasing, right? So in this particular case, what we get here is that interval of increasing for this particular function is between minus infinity to minus 1 and from 5 to infinity. And it is decreasing within this interval, which is minus 1 to 5, correct? You could also do as we did earlier, take test points. You could take a test point here as, let us say, we take a test point here as 0, take a test point minus 2 and 6, and check your derivative. It is going to be positive in this interval, negative here, and positive there, right? Giving you the result which we are expecting. So in the third case, let us do the same analysis. So here, the critical number for us is minus 3. Let us say this is minus 3 for us. Now, if I take a test point on left side of minus 3, let it be minus 4. On the right side, we could take 0. Then the derivative, f dash minus 4, is going to be negative, right? It is negative. So we'll say it is less than 0. On the other hand, the derivative at 0, if I put 0 here, I get plus 3, right, on the top over something which is positive. So that is going to be greater than 0. So in this particular case, interval of increase is from minus 3 to infinity. So we'll write this minus 3 to infinity. Interval of decrease is from minus infinity to minus 3. You get the point, right? So that is how you could answer this question. Now let us go through it once again. To find interval of increase and decrease for the function from their derivatives, we need to first find the critical point. That is the points where the derivative is 0. So list out those points. In the first case, it is 0 at x equals to 3. In the second case, derivative is 0 at 5 and minus 1. In the third case, we have 0 for the derivative at minus 3. These zeros are basically turning points on the function. So these zeros gives you turning points, right? At turning point, the slope will be 0. So that's the whole idea. So the turning points are at these given points. Now we have to check around the turning point whether the function is increasing or decreasing, right? So that is what we need to check. So we checked it here and we made two columns. One column we wrote for the solution of increase and the second one for decrease. Now if you test on either side of the 0, then just substitute the value, see the sign. If the sign is greater than 0, that means positive, then it is interval of increase. If you get derivative of the function as negative, then it is interval of decrease. So on checking, we can find out all the answers and list them out as we listed. So go through this. I hope that makes things very clear and it helps you to understand the basic concept. Thank you and all the best.